Hello, everyone, and welcome to today's SANS webcast, Dominating the Active Directory. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Erik Van Buggenhout, SANS Certified Instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Erik.
Thank you, Carol, for the nice introduction, as always. So good evening, everyone. Well, at least it's my common joke. For me, it's the evening. It very much depends on where you are located. I very much appreciate everyone taking a bit of time to walk through a couple of interesting topics that we want to have a chat about. Today we'll be talking a lot about how the overall Active Directory can be what we call dominated. So what does an adversary do when they achieve elevated privileges in the Active Directory? So what are some of the next steps? How do we move forward? Because quite often one of the things that you'll see is that when an adversary obtains access, or a pentester obtains access to the Active Directory, when they get domain admin access, if you will, that's not where it stops. In the end, that's only the beginning, because this is where, for me at least, the interesting stuff starts. Before we get into the nitty-gritty details and we get into the content, a quick introduction. So my name is Erik Van Buggenhout. So who am I? A bit more of information on that. Wait. For some interesting reason, my PowerPoint doesn't.
Oh, you know what? I bet it's still paused.
It's not paused, I guess. It's I don't know. 1 second. This is the first time I'm having it. It's playing, but it doesn't like to. 1 second. I will just restart my PowerPoint. I found one interesting way of fixing it. If I press right on my MacBook, for an interesting reason, it doesn't proceed the slide, which is very weird. But I found an interesting way to do it, because I have the slide bar on the, how do you call it, the touch bar. I can actually make it forward that way, which will work as well. So short introduction, who am I? So I am Erik Van Buggenhout. I've been involved with SANS for a while now. I do a couple of interesting things, at least I think interesting. One of them is 599, 699, so 2 courses that I've been building, where I've been looking at writing courseware around adversary emulation. These are what we call a bit more purple, if you will, so both red and blue stuff. How do adversaries operate and how can we detect and prevent them? I'm also the co-author of 560, which is a very recent evolution. So most of you will know that Ed is, of course, the initial author of 560. Recently, myself and Tim Medin have been working on adding some more updates and working further onto that courseware. So some of the things that we've been doing, for example, is focusing on some Active Directory stuff, adding some content on this topic, which is something that we've added into the courseware very recently. I think the first new version that we built went live a few weeks ago. So this is now, well, available in 560. So we focus quite a bit on Active Directory attacks. Kerberos, for example. Tim Medin actually did a webcast a few weeks ago on Kerberos, which was very interesting. So if you'd be interested in that one, feel free to open that one up as well. As you know, a SANS webcast can always be followed afterwards by registering and by downloading, of course, the slides. Next to my SANS activities, I also work at Enviso, which is a European cybersecurity firm, where I'm one of the co-founders, and we do a number of things, but my main focus area is threat hunting and adversary emulation. So I'm a bit in between of blue and red, if you will. So today's topic is domain dominance. So as I mentioned already shortly during the introduction, while you're conducting a penetration test, so if you are a penetration tester, at one point you might obtain an elevated privilege in the Active Directory. I typically like to call it the ultimate Active Directory privilege, if you will, domain admin / enterprise administrator. So once we get into domain admin rights, This is where it gets interesting, because we are typically paid as pen testers or adversary emulators to show a potential business impact when something goes wrong. What if an adversary obtains access to the domain? What can they do? Well, quite simply put, once you get domain admin rights, you're almost only limited by your imagination. And that, of course, means that business level manipulation becomes very interesting. Once an adversary gets domain admin level access, they can, of course, perform their action objectives, try to exfiltrate data, manipulate certain data. Very much depends on what they're looking for inside your environment. But for them, that's where it gets really interesting. From a technical level, though, and that's what we want to mostly discuss today, they could also try to persist that kind of access. We all know persistence strategies like having a scheduled task, implementing a WMI event subscriptions, having a service installed on a system, but we can also try to persist our elevated domain admin rights onto the Active Directory, and that's an interesting concept. So how can we achieve that, or how can adversary achieve this? Furthermore, they could use the domain admin level access that they've obtained to a certain domain to further pivot into other domains or even into other forests. So those are the topics that we will be discussing today. So very much a focus on the technical topics, less on, of course, business level manipulation. Why? Well, very simply put, because business level manipulation, of course, depends on the goal, on the objective, on the target environment. So let's get started. If you have any questions, do note that we will have some time available for questions after the webcast. So persisting administrative domain access. A couple of strategies here. So I just listed a number. I have dumping the entities.dit file, which I'll discuss all of them in detail, creating a domain admin account, which is a very obvious one, Kerberos golden tickets, skeleton key attacks, which is also Kerberos related attack, DCSync, and of course DCShadow. After we discuss these, we'll further discuss also the pivoting between domains and forests, but we will start with these topics, which are all also covered in SEC 560 in a lot of detail. So first up, dumping the entities.dit file. And now this is a very common one, is also very often performed by adversaries. What is the entities.dit file? The entities.dit file, of course, is the full dictionary, if you will, that includes a lot of the Active Directory information. More specifically, it includes a lot of the Active Directory secrets, or all of the Active Directory secrets. What are the Active Directory secrets? It's, of course, the password hashes of the users and of the different accounts that are available, and the Kerberos encryption keys. So once you obtain those, well, then you, of course, obtain access to every single user in the environment. So how can we achieve this? Well, once we get access to the domain controller, a very often seen trick is that we try to exfiltrate the entities.dit file, which is typically in C entities.dit. Now, how can we get to it? The file is available. If you have domain admin rights, you have the privileges to get it. Just know that it's by default locked by the operating system, because of course it uses it to perform its normal functions. So what an adversary would need to do is use the volume shadow copy service, for example, to create what we call a read-only copy to allow a proper copy of the entities.dit file to be extracted. Note that the hashes are not just in plain text inside the entities.dit file, they are encrypted. They are encrypted using the sys key, which is available in the registry of the domain controller. So that does mean if we have domain admin level access or local admin access to a domain controller, we'll be able to obtain both of those assets. So both the entities.dit file and the sys key that we'll need. One small caveat here is that we've seen environments where badly secured backups of the domain controllers are available, which could potentially also expose an entities.dit file. So very much an entities.dit file, a compromised entities.dit file means a compromised Active Directory. Creating a domain admin account, obviously I won't spend too much time here, but I do think it's important to mention this. But if someone gets domain admin access or domain admin level access, they can of course create their own user accounts. You might think that's just crazy, it never happens. It does happen. And during pen tests, I've encountered many different stories. Some of them more interesting than others. But to give you an idea, I've done this in a number of pen tests to make a point, to just show them, look, let's try to do something very intrusive and see to what extent I'm being detected. In one very interesting case, I created a domain admin account and nothing happened. So I thought, it's interesting. There's no reaction from the blue team whatsoever. I had made it a little bit stealth, because what did I do? This was in an Eastern European environment that I was working in. Now, I actually looked at the names of their how do you put it, the names of their national football team or the national soccer team for our American friends, of course. And I used a name of the national goalkeeper, which was interesting because it's a very traditional name in that environment. I just used that one as a domain admin account, and no one even bothered to look into it. They just assumed it was a new domain admin account which was being created. So it's not because a technique is noisy that it will get detected, because there's still a human, of course, who makes a call whether he or she is going to raise an alarm or raise an alert. That's an interesting one. So of course, creating a domain admin account, this is a GUI example, very easy to do as well using the net user command. But note that this is an interesting possible avenue. Another horror story here, which I like to add, is that in another specific pentest that I was working on, at the very end of it, I also created a domain admin account with, of course, a strong password. And I told them, look, that was the flag that I planted to show them, look, I got domain admin access, which was agreed upon. And we told them to get rid of that account once we're finished. So we gave them all the documentation, and we were hired again the next year to do our penetration test. And you can already guess it. We just thought, let's maybe try to see if that old account is still here, because we still had the password in our password vault. And well, very much so, that account was still there. So that gives you a bit of an idea of how this can be very interesting. And now it's, of course, a very dramatic scenario. And to be fair, this is not a very advanced technique. It's very simple, very straightforward. And we would all hope, of course, that most organizations would successfully detect this. Now, golden tickets is the next one that we want to discuss. In order to understand golden tickets, we also need to know what Kerberos is all about. So if you've seen the webcast by Tim Medin, don't worry, I'm not going to repeat all of his stuff, but it's important that we do know what Kerberos is all about, how it works, because that allows us to also understand how a golden ticket works. So in this case, I'm using a user account called Tim Medin or tim.medin, and I chose a very interesting password of I love Kerberos. What am I doing here? I'm setting up an authenticated session to a file server. So I want to obtain access to a file server. So what happens? How does this work? First up, most people know that Kerberos is based upon tickets, right? So we all know that there's tickets being involved. And a lot of people also know that this means TGTs and service tickets. Typically, those are the two main types of tickets. So the TGT, we could compare that one as the passport, if you will. It basically tells you that you are Tim Medin or Erik Van Buggenhout or whoever you are. It validates your identity, while a service ticket is used to specifically get access to a certain service that you would like to access. So what goes on in this flow? I first request authentication. So I send the authentication request. So I try to convince the domain controller that I am indeed Tim Medin. If the domain controller agrees with me and tells me that I'm Tim Medin, I will receive what we call a ticket granting ticket, or a TGT. Afterwards, I can use this TGT to request a service ticket, for example, to the file server. The domain controller will provide me with a service ticket, which I can then subsequently use to try to gain access to the file server. Now, what we see in the middle of this slide is the different Kerberos encryption keys that can be used. And they are relevant, they're important. We do need to realize, though, that for a golden ticket, the encryption type doesn't matter from a prevention point of view, because there is no prevention. What's important, though, is that from a detection capability or from a detection perspective, using RC4, as here on the slide, might reveal that something's up. Why? Because most of your activity will typically be AES these days. More on that in a second. So a couple more details on this. So looking a bit further into this process, or what's going on here. So the first request is the authentication request. So we can see here that Tim or Tim Medin enters his password of I love Kerberos. Small remark, Tim Medin is also on this webcast. He's actually flying now, so he probably can't hear me now because he's on the plane. He was planning to be here, but is unfortunately flying around. So in his dedication, if you will, or to honor him, I actually put his name in the webcast. So there we go. So he enters the password I love Kerberos. What happens is that the system, the local system, will generate a Kerberos encryption key based upon that password. Depending on the encryption type that is used, a different key, of course, is generated. For the purposes of this explanation, I'll assume that we're using RC4 as an encryption type. So what happens is that the RC4 encryption key gets generated, which in fact is nothing more than the NT hash of the password. So for I love Kerberos, a certain NT hash is generated, and that one is used to encrypt a timestamp that is sent to the authentication server, which is the domain controller. What does the domain controller do? Well, the domain controller stores all of the secrets. So it also has the NT hash of Timidine. It also has all of the encryption keys of Timidine. So it will then try to decrypt the timestamp to validate whether this is indeed a timestamp that was encrypted by Timidine. Very straightforward if you think about it. It's a very simple mechanism, if you will. What is returned is a TGT. So what is inside this TGT? This is where it gets interesting. The TGT has a lot of information. For one, it includes information about who is this person. So this is Timidine. So you get information about the TGT, which has information about the renewal time, the start time, the date. It also has information about the username, the person who actually created it. Do note that I have Alan Marshall here. I just noticed that. That, of course, should be Timidine. So that will show me for updating my name last minute when I heard that Tim was not joining. So here you can see that I have a username, Alan Marshall. In this case, it would be Timidine, of course. So it has information about the ticket, about the TGT. So we understand who is actually using this ticket and who does this ticket represent. So that TGT can afterwards be used by Tim to request additional service ticket. What's important here is this privileged account certificate includes all information about who a user is and what groups he has access to. So the most sensitive part of this TGT is the privileged account certificate. You can also notice that it's signed 2 times. It's signed using the target long-term key and the KDC long-term key. Small detail about Kerberos. We have 3 keys in Kerberos. One is the client long-term key. That's the one that's here in the middle of the screen. That is indeed the encryption key created by the client. So that's the NT hash, in this case, of Timadine's password. The target long-term key for a TGT is the encryption key of the KRB TGT account, because the target of a TGT is the target service that will validate a TGT. This is always the KRB TGT. Finally, the KDC long-term key is also used to sign. Note that the KDC long-term key, you guessed it, it's also the KRB TGT encryption key. So the pack is twice signed off by the KRB TGT, which is very interesting. More on that in a second. So what does all of this mean? Well, this means that when I now send my TGT, or when Tim sends his TGT, he will request a service ticket, for example, to gain access to a file server. He will receive a service ticket, which includes some interesting information. So what kind of information? The domain controller will validate the TGT and will take out the privileged account certificate for Alan Marshall or Timidine and will copy that privileged account certificate inside a service ticket. Now, the service ticket has 2 parts. There's a client portion, which is actually not relevant for our purposes because it's available to the client. He can read it, he can get all of the details out of it. But the sensitive part very much here is the server portion, because this one is encrypted using the target long-term key. There is a privileged account certificate in here, which is subsequently used by the file server to validate what privileges Alan Marshall or Timidine have. So what does that mean? It means that when a service ticket is created, the domain controller doesn't even validate whether or not Timidine has access to the file server. It will blindly copy over the pack from the TGT into the service ticket and will leave it up to the file server afterwards to verify whether or not Timidine has access to the file server resources. The reason for this is resource performance issues, if you will, to offload the domain controllers or the centralized infrastructure. Now, this is all Kerberos details, so I won't go too far here. If you're interested in that, there's plenty of Kerberos webcasts that both myself and Tim have done as well, so we can keep on going for this. It's important background information, though, to understand the golden ticket. Small note here as well, the pack signatures, they are typically not validated or only validated in very specific cases. For a TGT, the contents of the pack are only validated when the TGT is more than 20 minutes old, and that has a very interesting side effect. Furthermore, for a service ticket, those pack signatures are not validated for typical services on modern Windows. Bear that in mind, and I'll come back to that later, but this is a very interesting feature which allows us to do some very interesting things with Kerberos. So what's a golden ticket? Right? Enough with this whole introduction. A golden ticket is nothing more than a TGT that was created by the adversary or by the penetration tester. When can we create a TGT? Well, it's simple. we need some information which is publicly available, for example, the SID of the domain and of a potential user that we would want to mimic. It could be a domain administrator, as in this case. Could be any user that I would like, right? I could just write it myself because remember, I'm writing my own TGT. In order to make a valid TGT though, what do I need to do? Well, I need to be able to encrypt this entire thing using the KDC long-term key. So what do I need to be able to write a golden ticket? I need to compromise the encryption keys of the KRB TGT account. Again, this is domain domination or domain dominance. Once we get domain admin level access, I can of course obtain that key. So I can update that encryption key. So I could then use that to create a TGT, which has some very interesting features. You can see here on this slide, I'm creating a TGT, which is actually valid from the 5th of December 2018 to the 5th of December 2028. Interesting, so it's valid for 10 years. This is the default setting that actually Mimikate uses, but in theory, you could write your own. You could put any date in there, that doesn't matter, because Kerberos is what we call stateless. Whatever is in the ticket is accepted by the domain controllers, because the domain controllers assume that a valid entity, another domain controller, if you will, wrote a certain ticket and to respect whatever is in the ticket, which is very interesting because that allows us to do some very interesting things. I use the word interesting a lot, I just noticed. So there we go, username, domain admin, SID, and then I specify some domain admins. Remember that all of the secrets I need to create this TGT and to sign off on the pack, I have them, because for a TGT, the signatures are done with the target long-term key and the KDC long-term key, which are both the KRB TGT encryption keys. Once I have that one, I can create my own valid TGT. So what does that mean? That means that instead of priorly sending that encrypted timestamp, when I'm using a golden ticket, I will just suddenly appear and I will send a TGT and I would say, hey, look, here's my TGT. I'm domain.admin and my ticket is valid for, well, the next 10 years. I would like to gain access to the file server. What will the domain controller do? It will validate the TGT and everything will check out, unless, I'll talk about that a bit later on, what's the unless, but of course this is a perfectly valid ticket. You might argue, but Erik, it's valid for 10 years, that doesn't make sense. Indeed, that doesn't make sense, but do note that Kerberos by definition or by default is stateless, so it doesn't care. It just looks at the ticket, validates it, and it will proceed. It will not care about this. There are solutions like ATA, for example, and there are a couple of actually commercial products which are trying to build what we call stateful Kerberos, where they try to map what TGTs were initially issued by a domain controller to spot TGTs which were not issued by a domain controller. The reason why this is complicated and why it's not happening by default is that in most enterprise environments, you'll have many different domain controllers. And of course, even if you have 300 different domain controllers, you want a TGT that was created on domain controller 1 to be also valid when it's being tested or sent to, let's say, domain controller 201, right? Because they're all part of the same domain. So what happens here, or what's so special about this TGT? First up, it's made without any interaction with the DC. Once I have the KRB TGT, I can go back to my basement, if you will, and just write my own TGT. It will require the adversary to obtain the KDC long-term key. So that's the encryption key of the KRB TGT account. Again, this should not be easy to get, but we're talking domain dominance here, right? So as an adversary, as a pen tester, once I have this type of access, I will be able to get it. It's typically a TGT for a highly privileged account, for example, RID 500 in the domain, or, well, any account you would like, and it's typically valid for a long time. So this is what that looks like. Here I'm using our beloved Mimikate tool to create my own golden ticket. Very simple, it's pretty straightforward. You can see the command line here. I'm just specifying Kerberos golden. I'm adding the KRB TGT and T-hash. So in this case, I'm what we call creating an RC4 golden ticket, specifying the username, which is root, the domain sec560 private, the SID of the account that I'm mimicking, and I'm writing that to a file called golden.ticket.pin. We can then afterwards import that, and then of course we become, if you will, that specific user. So in this case, root in sec560 private. So again, the only thing we need here or the only secret is the KDC long-term key. All of the other information, for example, the SID of a domain, if you've done some domain reconnaissance, it's very easy to obtain if you are an authenticated domain user. You do not need any privileges for that. So that's pretty straightforward. Do note that this would be an RC4 ticket, which might be something that you want to look for. So this is me then using this golden ticket. So pass the ticket golden.ticket bin. And here we can see that this ticket gets loaded into memory. And you can see that it has a few interesting features here. For example, this specific one in this example screenshot is made 10 July 2017. And it expires on the 8th of July 2027, which is fairly interesting. Now, how do we make sure, or how do we defend against that? As a small pointer, you cannot stop this from happening. What I mean by that is you cannot stop an adversary from writing his own TGT once they have access to the Kerberos long-term keys. Of course not, because they do it on their own. They do it in their own infrastructure. What we can do, though, is invalidate those tickets. And how could we do that? Well, when the domain controller tries to validate the TGT, it will try to validate the TGT both using the current Kerberos long-term encryption key and the previous one. The reason for that is a bit of grace period, if you will, or to make sure that there's no replication issues when the password hasn't been fully synchronized across the entire fleet just yet. So that means that, imagine that I'm Erik, I create a golden ticket today. Tomorrow, you have an indication of a potential compromise and you reset your KRBTGT password twice. Be careful though, if you do it, you cannot do it immediately straight you cannot do it now and then in 5 minutes again, doesn't work. You're going to break your AD, but you can do it in, let's say, after 10 hours, and I'll get back to that later on, why that can be done. Be careful though, this will have a production impact. But the idea is, if you change it twice and then I try to use my TGT, that means that my TGT is now no longer valid because the KRBTGT encryption key has changed. Note that by default, KRBTGT encryption keys don't change. There's no periodic change in there. This is more and more becoming a best practice, though, that's being recommended. But formally, it's not something that's done officially or formally or even automated by a domain controller, for example. It does change on a number of occasions. For example, if you upgrade your domain functional level, KRBTGT account will also change. The password will also be updated, which is fairly interesting. A skeleton key attack then. If we understand Kerberos sufficiently, will be easy. It's pretty easy to understand what a skeleton key is all about. The skeleton key is also Kerberos attack strategy. A skeleton key is pretty nasty. It's a backdoor that we install in memory on the domain controller. So how does that work? Well, the skeleton key only works for Kerberos RC4 encryption. How does it operate? We will now implement a backdoor in memory of the domain controller, which will make the domain controller, or the KDC, validate an encrypted timestamp using the expected encryption key, but also another encryption key. So let's go back here for a second. When I'm Tim Medin or Erik Van Buggenhout, what I do is I take a timestamp and I encrypt it using my encrypted or my encryption hash, right? My encryption key. So I use, for example, my NT hash if it's the case of RC4. So I'm Erik Van Buggenhout. I take my NT hash and I use that one to encrypt a timestamp which I send to the domain controller. The domain controller takes that encrypted value and takes, of course, the NT hash for Erik Van Buggenhout because it has it stored. It's the domain controller. It has all of the NT hashes. It tries to decrypt that. If it works out, it knows that I'm indeed Erik because I know Erik's NT hash. I just used it to encrypt the timestamp. Perfect. The skeleton key, however, says, okay, that's fine. Try to decrypt that value using the NT hash of user Erik. And if that doesn't work out, don't stop just yet. Also try to decrypt it with this timestamp, with this encryption key. With what encryption key? Well, the standard NT hash for the password Mimikate. This means that if this gets implemented on your domain controller, every single user in your domain can be authenticated to using the original password or the correct one and the password Mimikate, which is interesting. So it's if you can access your account with the password Mimikate in your enterprise environment, it's time to burn down the data center. That's something you absolutely want to avoid. Do note that this runs in memory. It doesn't change the actual password value, right? It just backdoors how the domain controller operates. Again, this would require local admin access to the domain controller, so it's only something that can be done once we get into domain domination, if you will. You could, of course, persist it if you script that, if you do it every time that the domain controller boots. Also note that an adversary, in order to have maximum effect, would have to backdoor every single domain controller. So it's not easy to pull off, but it's very insidious, if you will. Interesting trivia here is that this was implemented in Mimikate, but it was inspired by an actual APT who used that in 2015. So they actually implement a skeleton key malware on a domain controller. This was identified by an incident response team, and afterwards this was used as inspiration by Mimikate, which is fairly impressive. So here we can see the skeleton key in action. It's remarkably easy, and that makes it also pretty scary. Privilege : debug to obtain the debug privilege, and then we just implement the skeleton key backdoor by using the miscellaneous and then the skeleton function. Once this is done, every single user will be able to authenticate to any account using the password Mimikate. Mimikate, the product or the tool, does not provide an easy way of changing this encryption key. So you cannot change it to another value. Do note, of course, that theoretically it's very easy to do that. As Mimikate is, of course, open source, an adversary could perfectly adapt that or even write his own mechanism here with his own value. So it's not just Mimikate. But just know that the standard Mimikate tool will not allow you to customize this value. Moving forward, DCSync. So I know there's quite a lot of things that we're going to discuss, so I'm moving at a certain pace. But if you have any questions afterwards, of course, you can feel free to find me, or even if you're rewatching this and you want to reach out afterwards, I'm very happy to respond to any questions or remarks you may have. So what's DCSync? DCSync uses domain replication. So what is domain replication? Well, in most enterprise environments, there's obviously more than one domain controller. Those domain controllers need to be in sync. Because if I update my password on domain controller 1, I want it to be replicated across the entire fleet. In order to do this, domain controllers speak a certain protocol to one another. It's called MSDFRS, which is the Microsoft Directory Replication Service Replication Protocol. So any account which has those privileges, and I listed them here, the replicating directory changes all, and replicating directory changes in filtered set, any account who has those privileges is able to pull off this attack. Now, what does this attack allow you to do? It's very straightforward. It allows a user to talk to a domain controller and to request replication. Replication of what? Well, of course, of the secrets. So I could just say, okay, give me all of the encryption keys that you have. Because remember, this is full-blown replication. So I'm able to just copy everything that the other domain controller has. So I could request the domain controller, the target that I'm talking to give me all of the secrets that he has currently on file, because I'm trying to replicate, which makes a lot of sense. Domain administrators and domain controller computer accounts have these privileges by default. Some other accounts could have it as well, but that would be a misconfiguration. But so DCSync is a fairly interesting strategy, or a fairly interesting attack approach. So here we can see it in action. It's fairly simple. LSA dump : DCSync, specific user. In this case, I'm targeting user administrator. And what's going on here, we can see that sec560.private will be the domain. I'm targeting a certain domain controller, which is that specific value there, the WinPG-F4RHUE40J. And I'm targeting the user account administrator. So what comes back? It dumps all of the secrets and all of the properties of the administrator account, which is fairly interesting. So I can get all of that information. I can just pull it out. This includes the NT hashes, the encryption keys, the Kerberos encryption keys. So basically, this means you're doing NTDS.dit dumping over the network, if you will. DCShadow, building forward on this, we can also use DCShadow. So what is DCShadow? We can take this a step further. This is similar to DCSync, but it's actually a bit more stealth and a bit more dangerous as well. So what do we do with DCShadow? This is a pretty new attack strategy, which was highlighted by Benjamin Delpy and Vincent Ledoux in 2018. We again need to have elevated privileges. That's for every single attack that I'm discussing today. What we'll do now, however, is take it a step further. We will now have a workstation that registers himself or itself as a domain controller. So there's suddenly a new domain controller onto the environment. Then on that machine that we've compromised or that we're using now, using our domain admin account, we will craft a change in the schema. So we'll make it look like, hey, look, there's something here. For example, a sensitive account has its password changed. We then trigger replication. What happens? It's actually the other way around. This time, I'll make the other domain controllers come to my machine, to my workstation, which is now a temporary domain controller, if you will, and I will tell them, look, I have an update. The password of that user account has changed, for example, which will then replicate, right? Because I'm using that replication again. This time it's the other way around. I'm not trying to read information that's available on another domain controller. I'm trying to influence information that's on another domain controller. So I'm actually making changes to the schema, and it gets uglier. Because imagine that you, let's say, create a user account, right? You create a user account on a certain system, on a certain domain controller. It's fine. That means that that event ID of that user that gets created is logged on that specific domain controller, right? What happens though if I use this attack to make a change, and then of course I spread it around because I trigger replication, which means that my change now gets persisted onto all of the other domain controllers. The domain controllers will log. If you enable replication logging, or if you have detailed verbose logging for replication, they will log that replication took place. They will not log exactly what changed because they rely on the original domain controller to keep track of what happened there, right? In this case, though, that original domain controller doesn't exist. It's me, it's the adversary, it's the attacker. So your original log disappears. So this means that it's not too hard to detect DCShadow, but it's very hard to know what actually was changed. You know that something happened, but you don't know what, which makes it pretty dodgy and pretty hard to defend against, if you will. So here's again a small screenshot and a small update of what that looks like. LSA dump : DCShadow. This time I'm targeting a certain object. I'm using the administrator object here of a fictional environment called the synteclabs.com. And what am I doing here? I'm updating the description of the administrator, and I'm adding as a value DCShadow was here. You can see here the information about that is being prepared. So that change is being prepped, if you will. It then starts up the server. So it makes itself available for application, if you will. Once that's done, or once that's running, we open a second window and we initiate, my apologies, and push a replication push. So LSA dump : DCShadow push, and we can see here what happens. Server information. So we can see that there's a dc.synteclabs.com, which is the valid domain controller, and we can see that there's also a mention of fake server. This is almost in the middle of the screenshot, if you will. Fake server not already registered, windows02.synteclabs.com. So the Windows 02 becomes a temporary domain controller and then pushes, of course, its update. So the dc.synteclabs.com takes this, and of course, I have now successfully made a change into the AD schema. So, defenses. Most of the defenses that we'll talk about, and I'll be very brief because this is, of course, a pen testing talk and it's a lot more focused on the offensive stuff. It's hard to defend against this because at this point, the adversary for all of these different techniques has elevated privileges inside the domain environment. So it's very hard to stop them. If you wanted to stop them, you should have done it before this. From a detection perspective, there's, however, a couple of interesting approaches and things that we can try doing. First up, the creation of a golden ticket cannot be detected because it happens offline. That being said, you could try to spot the fact that it's being used. For example, hunting for TGTs in memory, which have an unreasonable long validity time, for example, using the built-in klist command. We could also try to build, and it's not on the slide, but we could try to build what we call a stateful Kerberos, which is something that a couple of commercial products are trying to do, and which ATA, which is a Microsoft commercial product, is kind of doing as well, because they try to keep track of, okay, but what's going on here? When we see a certain TGT being used, did we ever issue that TGT, that kind of stuff, that kind of analysis? That's not something that's built into AD though, which is interesting because that opens up a lot of opportunities for abuse. But there's a couple of things that we can try doing there. DCSync and DCShadow, not too hard to spot. Why not? Because if you see replication traffic between anything else but two domain controllers, then you know that something's up. So for DCSync, that's the only, or the only very effective, if you will, technique of trying to spot that. It doesn't mean though that you need to have visibility on what kind of traffic you're seeing between your workstations, for example, and your domain controllers. If those systems are all in one network zone and you have no visibility in what's flowing between those two different machine types, you'll never be able to spot it, which is tricky. So it's easy to spot if you have decent IT hygiene, if your domain controllers are nicely isolated in one network zone, and if you can actually see what's going on between your workstations, for example, and your domain controllers. DCShadow can also be detected because you can actually look for the temporary addition of a DC, which is pretty noisy, and which of course gets removed afterwards. So there's very specific event IDs for that, which look for directory service objects that are created and removed, because that's what DCShadow does. It actually promotes a workstation to a domain controller temporarily and then removes it. So that's another trick. DCShadow is pretty easy to spot. That being said, remember, the use of DCShadow can be seen, or it's not that hard to detect. What actually was done using DCShadow, so the impact, the payload, if you will, that's a lot harder to spot, because Windows relies on the original domain controller to log, of course, what changed. Pivoting through domains and forests. Now, all of this was nicely contained within our domain, right? In a specific domain, we can do a number of different things. Now, how could we pivot between two different domains? We could use the following approach. There's a couple of very interesting blog posts written by Will Schroeder or Harmjoy. It's very interesting researcher who works at Spectrops. He wrote a very interesting blog post on a guide to attacking domain trusts. So he writes an entire methodology or an approach, if you will, on how to achieve that. And a couple of steps, what you're trying to do is, one, enumerate the domain trusts to understand what kind of trusts are set up between the domain that you've compromised and potential other target domains. After that, we look for security principles, for example, user accounts that have cross-domain privileges, right? Because we want to find users which have access into another domain, which we might write on to get access in another domain. Finally, we of course try to identify and compromise the principles that we need to be able to do that. Now, this is an effective approach. It requires misconfigurations though, and it requires us to look for interesting misconfigurations, if you will. If the domains are in the same forest, however, there's an easier way. So there's a lot more effective way to jump from one domain to the other. Because remember that Microsoft formally does not use a domain as a security boundary. So domains in the same forest, they should not be considered to be isolated because it's the same domains. It's the same forest. Why? Or why is that? Benjamin Delpy, again him, there's a couple of very smart people who are working on this, and it's very impressive to see what they're doing. In 2015, he had the very interesting feature into Mimicates, which is actually mostly used in the golden ticket attacks. It uses a concept of an extra SID. Now, what is an extra SID? First up, we need to understand what SID history is. It's basically a term, or it's a different way of saying an extra SID. So once we had Windows 2000 Active Directory, we used extra SIDs as an option to allow migrated users to still know what their old SID was. Now, what's an SID? The SID is, of course, a security identifier. It means that I have a certain security identifier and I have a number of groups that I'm a member of. So I know these are the security identifiers that I have access to, right? The current ones. Now, what we can add though in the pack, so the privileged account certificate, is what we call extra SIDs. Those extra SIDs can include old SIDs, for example, that we used to have access to when, for example, account was migrated. You can already think, or you can already guess where this is going, because inside those extra SIDs, you can add your own. If you're writing a golden ticket, you're writing your own pack, you're writing everything yourself. So you could also write your own value into the extra SIDs. So what we would do here is we would write, for example, 519. This is the second point of SID filtering, an SID which ends in 519. What is SID 519? It's the enterprise administrators group. If I add that to my own pack, that means that my domain administrator is now also a member of the enterprise administrators group. An enterprise administrator is defined at forest level, right? So that means that you've compromised every single domain inside that forest. Very interesting. Note that this works inside the same forest. So this, when this was published, was the very first practical example, or the easiest way to show that if you compromise one domain fully inside a forest, you've just compromised all the other domains as well, because of this issue with SID history and SID filtering, which is fairly interesting. So there's a lot of documentation that Microsoft also provides on this topic, but that's a pretty nice tech strategy, if you will. Now, on to the more interesting part, pivoting between forest trusts. This was first introduced by Will Schroeder and some of his colleagues. I have them all listed on the next few pages. There is, however, a fix for this one, which was published by Microsoft, or even pushed by Microsoft a few months ago. Now, what they actually found out was that there's a very similar tech strategies, which also works across different forests. So they managed to pivot from one forest to the other. Now, initially, Microsoft had kind of a response to that, saying, well, it's not, it's kind of like by design, but then they also realized, wait, the initial statement was a domain is not a security boundary, but a forest is supposed to be a security boundary, right? So that's something that we do need to fix. So they released a fix for this, which effectively fixes the issue. This is a specific CVE that's there. But it's interesting, though, to look into this tech strategy, because, of course, we all know that we can sometimes still encounter legacy systems. And it's also just interesting to understand how this works. This relies on an interesting attack strategy, which is called unconstrained delegation. So let's have a look, right? First of all, know that two things: domain controllers are systems that are configured by default to have unconstrained delegation. Secondly, TGTs, so ticket granting tickets, are delegated across forest trusts by default. What does that mean? So let's first have a look, because most of you might have not heard of unconstrained delegation. So what is delegation? It's a Kerberos feature that allows a service to execute actions on behalf of a user. For example, a web server, front-end server that needs to interact with the backend server in the place, or in the needs to impersonate a certain end user inside the database server. That would be an example of delegation. So that means that the web server would need to impersonate the end user towards the database. Initially, Microsoft used unconstrained delegation. This was the normal form of delegation. This is the only one that we'll talk about today, because otherwise it would bring us a bit too far, which allowed a very interesting way of doing delegation. This is also currently considered a highly insecure way of doing delegation, but remember that domain controllers have it by default, which makes sense though, but that leads to an interesting attack strategy. First of all, we need to understand what unconstrained delegation is about. Note that Microsoft introduced, as of Server 2003, traditional constrained delegation, and as of Server 2012, resource-based constrained delegation. Both of those are out of scope though. There are attack strategies against those as well, very interesting ones even, but they're a bit out of scope for this specific webcast. We're going to focus on the unconstrained delegation type here. So what is unconstrained delegation? We already talked about Kerberos. We explained what it is all about. What happens if a user John, for example, wants to use a service A, which is configured for unconstrained delegation? So user John will run through the normal Kerberos process. He requests a TGT. That's the first arrow. He receives a TGT, of course, if his encrypted timestamp that is sent is valid. And then it will say, I want to request a service ticket for John, right? Because I'm user John, to service A. That's my third arrow. The domain controller will realize that service A has trusted for delegation. This means unconstrained delegation. So this is a flag that is set on that service account. So the domain controller knows that it has to do something very specific with that service ticket that it's going to return. Instead of adding the pack for John inside the service ticket, it will actually put the entire TGT of John in the service ticket. This is now returned to user John, and John, as usual, uses a service ticket, so that's my arrow number 5, towards service number A, or service A. What does service A do? Of course, it can extract the service ticket, because that's normal Kerberos flow. It will do a number of things, do its normal operations, but it will also extract the TGT of user John out of the service ticket. Now, if I have the TGT, or if service A has the TGT for John, it now just became John. right? There's no constraints here, hence unconstrained delegation, because service A now has a TGT for John. So it can then request, error number 6, a service ticket from the domain controller for John to service B. So now service A can impersonate John to service B. This means that service A has no constraints whatsoever and can now pretend to be user John to every single system in the environment. So you can imagine the security issues and of course implication of that. This is not something you want to have in your corporate environment, or not something that you want to have. So here again, we can see that in the small screenshot here. This is a service ticket here that we can see. Instead of having just a pack, now the entire ticket granting ticket is inside the service ticket, which is very impressive, and which is of course something that we absolutely want to avoid. Now, I guess this makes sense, but we haven't talked about why does this affect those forests, right? Because what does this mean? Well, imagine how we could abuse unconstrained delegation. First step, we need to identify accounts that have Kerberos unconstrained delegation. Domain controller computer accounts have this enabled by default. Any other account that has this enabled is typically a legacy account or a legacy system, or of course a misconfiguration. Once you have identified a suitable target, we need to compromise it. And then of course, we want to lure someone to connect to that service, because that would mean that the service ticket that is sent includes a TGT for your victim. We can then dump the TGT and we can abuse it. I'll walk through these steps one by one. Step 1, I want to identify systems that have unconstrained delegation. Right? In this case, here I have a GUI screenshot of trust this computer for delegation to any service of a Windows 01 computer account. In the GUI, we can easily spot that this is unconstrained delegation, right? So the second option there, trust this computer for delegation to any service, that's a longer term, if you will, for unconstrained delegation. You could say, Erik, we don't want to use the GUI to check these things. I added a couple of PowerShell commands here that you can use to spot these as well. So get AD computer, get AD user for computer accounts or for user accounts to spot accounts which have indeed, as you can see in the properties, trusted for delegation flag set. That means that they have unconstrained delegation. If you find any systems like this and they're not domain controller computer accounts, you do want to have a look and see what's going on, because that could potentially expose your entire forest and even other forests as well. Now, once you identify one like this, for example, Windows 01, you need to compromise it, right? Simple. Find a way to compromise that account. Maybe there's no way, right? But this is something that's a prerequisite. We need to find a way to compromise that one. So I mentioned as a joke here, use your favorite 560, 660, or 760 technique. Find a way to compromise that account. In the previous step, I used the Windows 01 as a computer account. So if you're a domain user and you find out that Windows 01 is configured for unconstrained delegation, you want to compromise Windows 01. Because if you get Windows 01, that's where everything falls down. Why? Because next up, you can then connect to that system and you can force an interesting account to connect. And here, Elad Shamir and Tifkin, they presented a very impressive attack strategy where they found out that by combining another vulnerability, they can force a domain controller to connect to such a system. Consider the following. I compromise a server, Windows 01, for example, which has unconstrained delegation. That's all I have in the domain. This server has nothing interesting, right? There's no interesting data. There's no credentials in memory. So I'm a bit stuck. I could use the printer bug. What is the printer bug? It's an interesting vulnerability, if you will, which is enabled by default and which Microsoft has currently, the statement is that they won't fix this, which will allow a remote system to forcibly have an RPC call from a system to another system. So what's going on in this small diagram? From any workstation in the domain, I abuse what we call the printer bug, and I force a domain controller to connect to a system that has unconstrained delegation. Now that connection will take place using the machine computer account. The machine computer account of the domain controller has DCSync privileges. Wait, what? What does that mean? That the domain controller computer account connects towards a compromised server using a service ticket, which has a TGT for the computer account of the domain controller inside that service ticket. Because I've compromised the compromised server, I can now just extract that from memory, and guess what? I now have a TGT for a computer account of the domain controller, which has DCSync privileges. Boom, right? So I can now do what I've discussed before. So I can start doing this. You could say, Erik, that does not matter when we're discussing cross-forest attacks, right? This is still the same domain. Yes, but it gets more interesting. So this is this in action. So that step, what we're doing here very practically, we're using Rubius, which is a toolkit developed by Will Schroeder mainly, which is Kerberos Swiss Army knife, if you will. A very impressive stuff, a very impressive work here. So I'm using Rubius to monitor for a TGT that's available, right? So I'm looking for here Rubius.exe monitor interval once means I want to refresh every second, and I'm looking for DC dollar. DC dollar is the computer account of my domain controller, my target, if you will. So I'm looking for TGTs. At first, there's nothing, right? Because why would the domain controller connect to that system? This is my compromised machine, right? So I'm waiting for the domain controller to connect. Now, from any other machine, what I'm going to do is I'm going to get the printer bug. This is one implementation of the printer bug. It uses an application called spoolsample.exe to force the domain controller to connect to Windows 01. So spoolsample.exe, DC, Windows 01. What's Windows 01? Well, it's that compromised machine. So what happens? We'll give him a bit of information. It will say, look, attempted printer notification and receiving invalid handle, the coerced authentication probably succeeded. Okay. Probably, right? That's always the thing with pen testing. You're never sure, right? So next up, we check again our Rubius window, and what do we see here? Yes, indeed, 4624 login event for syncteclab.com DC dollar from 192.168.5.5 TGT for username DC dollar. Boom, and we get all of the details. So we can see that we now have that TGT for DC dollar, and the entire ticket is available in a base64 encoded format at the bottom here of the screenshot. Excellent. So we can now either convert that base64 to a proper file and write it, or if you want to do it more complicated, for some reason I like doing it that way, I used Rubius.exe, passed the ticket, and then I just specified the entire base64 encoded ticket. Boom, that's the entire TGT. And I can now use that. Boom, what can I do? DCSync, and for example, get the care of a TGT account. So I now went from a system with unconstrained delegation to domain admin immediately, or to an account which has DCSync privileges. Very nice. Erik, that's still domain admins, right? How do you pivot from one forest to the other one? Well, simple. If you add this part, attacker compromises a system with unconstrained delegation in forest A, but wants to jump to forest B. But the attacker doesn't find any vulnerability in forest B. It, however, uses the printer bug to coerce forest B domain controller to connect the forest A domain controller. So the forest B domain controller tries to connect the forest A domain controller. Remember, the domain controllers are configured with unconstrained delegation by default. That's how they work. So the attacker can then extract the TGT of the forest B domain controller from the forest A domain controller, which now gives him DCSync privileges against the domain controller in forest B. So he now just compromised the second forest. It's a very interesting combination of what we call TGT delegation across forests, which used to be the default function, but since I think June or July 2019, this is no longer the default setting, and Microsoft patched this one, which is fairly impressive work. But this is a very interesting attack strategy, which showed a very easy and a nice way of pivoting from one system to the other. Now, I went a bit quicker here at the end. Again, if you guys have any questions, I have a lot of references here. Do have a look, because again, this is not all my research, obviously not. I'm mainly here, I'm the messenger, if you will, explaining a couple of these very impressive attack strategies. What I would like to say is, if you have any questions, then hit me up, because we're nearing the end of our webcast here. I also added a couple of links here. SEC 560 runs, if you're interested in that, 699, which is one of our new course. And of course, you can always reach out to me as well if you have any specific questions. Shout out to everyone that I mentioned in this presentation, all the security researchers. This amazing community, I think, is doing some amazing work, and I'm very happy and very fortunate to be able to talk about all of these different strategies. Any questions? I think I have 1 minute left.
Hey, Erik, this is Carol. Yeah, we did have one question come in. It came in about 35 minutes ago. It says, just for the record, you already need a DA account to create golden ticket, right?
Exactly. Yeah, yeah. To be more specific, you need the KRBTGT encryption key to create a golden ticket, but that typically means that you need a domain admin account. Yes.
All right, well, that's all we have. Thank you so much, Erik, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.